Welcome to this course on GitHub Advanced Security, where you will learn how to tackle real-world security scenarios as part of your DevSecOps and secure software lifecycle management. My name is Peter Ditender, a lead technical trainer here at Microsoft with a passion for DevOps, or maybe I should say DevSecOps. In this module, we start to dig deeper into the GitHub Advanced Security suite of security mechanisms, and more specifically, we're going to discuss the Dependabot vulnerability scanning feature. GitHub dependency management tools help you handle the security risks and maintenance requirements of incorporating third-party software into your projects. Imagine you're responsible for a GitHub repository. This project is built on several other pieces of software, also known as dependencies. These dependencies provide necessary functionality, but they also require proper management. You want to keep your dependencies up to date and also put processes in place to address any security risks or vulnerabilities that are introduced because you rely on software that's maintained outside of your project. And then you also want to automate this process and avoid delays in responding to important issues. Managing dependencies on GitHub is all about keeping your software safe, up to date, and easy to maintain. GitHub offers several powerful tools to help with this: the dependency graph, the GitHub advisory database, and the software bill of material, or also called SBOMs. The dependency graph acts like a map of your project's building blocks, summarizing all the packages your code relies on, both directly and indirectly. This map is automatically generated for public repositories and can be enabled for your private ones, giving you a clear view of what's under the hood. By understanding your dependencies, you can immediately spot potential security risks and make smarter decisions about updates and maintenance. The GitHub Advisory Database complements this by providing up-to-date information on already known vulnerabilities, so you're always aware of any risks lurking into your code foundations. Now let's take a closer look at some of the features. The GitHub Advisory Database is a free open-source repository packed with security advisories from across the software world. It provides detailed information about vulnerabilities, including severity and which packages are affected, using industry-standard scoring systems like CVSS. This basically means you can quickly assess the risk level of any issue and then take action before it starts impacting your project. Alongside this, the dependency review feature acts as a safety net by catching vulnerable dependencies before they're merged into your main branch. It analyzes changes in pull requests, showing you exactly which dependencies got added, removed, or updated, and flags any known vulnerabilities. This proactive approach helps you maintain a secure codebase and obviously avoiding surprises down the road. Another essential tool is the software bill of materials, which is like an inventory list for your project's dependencies. SBOMs are machine-readable and can be exported using the GitHub user interface or REST APIs, making them invaluable for audits and regulatory compliance. They help you identify vulnerabilities early and ensure your code meets data protection standards. Next, Dependabot ties all these tools together by automating dependency management, alerting you to vulnerabilities, updating dependencies, and generating pull requests to keep everything current. By leveraging the dependency graph and the advisory database, Dependabot ensures your project stays secure with minimal manual effort. Together, these tools empower you to manage dependencies confidently, protecting your software supply chain and comply with industry regulations. Dependabot alerts tell you that your code depends on a given package that might be insecure. If your project relies on external dependencies, you can use valuable resources trying to monitor them. This monitoring process is important because you must be aware of changes or vulnerabilities in your code. It can also be challenging because this code is not part of your project. GitHub helps to automate this process by monitoring your dependencies and then sending Dependabot alerts when it detects a vulnerable dependency in your repository. Because Dependabot alerts rely on the dependency graph, the ecosystems that Dependabot alerts support are the same as those dependency graph supports itself. It's important to keep your manifest and log files up to date. If the dependency graph doesn't accurately reflect your current dependencies and versions, you could miss alerts for insecure dependencies that you're using. You might also get alerts for dependencies that you are no longer using. GitHub security features don't claim to catch all vulnerabilities. Though we're always trying to update our vulnerability database and generate alerts with the most up-to-date information, we won't be able to catch everything or tell you about known vulnerabilities within a guaranteed timeframe. These features aren't substitutes for human review of each dependency for potential vulnerabilities or any other issues for that matter, and that's where we recommend consulting with a security service or conducting a thorough vulnerability review whenever necessary. That's where you have to keep an eye on the Dependabot security updates as well as the version updates, but also use your common sense if any other codebase information seems a little bit suspicious. Since we talk about package vulnerabilities, I also want to highlight the specific GitHub action for dependency review. The dependency review action refers to the specific action that can report on differences in a pull request within the GitHub Actions pipeline context, and from there adding enforcement mechanisms to that GitHub action workflow. Because sometimes you might just want to update the version of one dependency in a manifest and then generate a pull request. However, if the updated version of this direct dependency also has other updated dependencies, your pull request may have more changes than what you expected. The dependency review for each manifest and log files provides an easy way to see what has changed and whether any of the new dependency versions contain known vulnerabilities. By checking the dependency reviews as part of your pull request and changing any dependencies which got flagged as vulnerable, you can avoid vulnerabilities being added into your project. Dependabot alerts will find vulnerabilities that are already in your dependencies, but it's much better to avoid introducing potential problems than fixing the problem at a later date. So with that, I guess I owe you another set of live demos showing you the different capabilities of Dependabot for your package vulnerability scanning. So in this demonstration, you'll see how to, first of all, enable Dependabot within your GitHub Advanced Security. Next to that, how to analyze Dependabot observations and alerts. And then last, how to configure and run the dependency review action pipeline. So this demo is covering, I would say, 4 different tasks that we can perform using Dependabot. So I'm going to start with the first one that I would describe as main Dependabot capabilities. I'm using a sample repo, it's a public one, so feel free to maybe look into it, maybe fork it into your own GitHub environment. The repo is GH-500-Dependabot-demo. What I did for this one is going into the settings once more. And if we look into our settings, down here we have Advanced Security. And we have a set of options around dependency graph and a full section around Dependabot. Now, I have to be a bit honest here, where I'm not using any of the enterprise GitHub Advanced Security Enterprise options because I'm using my own GitHub account. I'm not running it in an enterprise environment. So that means that I would say 95% of what I'm going to demo here is identical in your environment. But if you do this from an enterprise account level, you're going to see that you have a few more options on organizational level or enterprise level. But it's basically going to settings on organization with a whole list of options or even defining them on enterprise level. The outcome, the use case is technically identical to everything I'm showing in this part of the demo. So once we enable Dependabot, where you can see here it is enabled and we could define some rules, but that's fine tuning. Didn't do any of that to make sure that I can show you all default capabilities. The outcome of that is if I now move to my security tab and I navigate to Dependabot here, it's going to show me the outcome. By the way, although I moved to settings, GitHub Advanced Security, the faster way to enable it initially is go into your security tab and making sure here that Dependabot is enabled. Once we enable Dependabot, after just a couple of minutes, typically, we see different Dependabot alerts. So in this example, it's some sample code, so nothing too specific. And obviously, it's not about the specifics of code. It's about detecting those vulnerabilities. So what we get here is a first alert, and I got 4 different ones, where we can see that it's highlighting what is the package, like the application code component, what is the affected version. So in this case, it's a JavaScript package that we use, and anything below version 4.17.21 is having known vulnerabilities. There's a short description here what that vulnerability actually means. In this case, potential risk for comment injection. And then also important is what is the fix, which in this example means everything that's newer version 4.17.21 or up no longer has that vulnerability. We can look into a few more details. Now, obviously, this is a short example, but this explanation could be a lot longer. But then here on the side, it also provides additional information. For example, the CVSS information. What is the network, or what is the attack vector in this case? The network. What are some of the impacted privileges? And we also have an EPSS score if you need to look into any of those numbers for maybe your reporting. I talked about integration with CVEs. That's what you have over here. But then we also have the CWEs, which reflects the weakness, not just the vulnerability. Interesting here is when I grab this CVE number and I move into the actual cve.org website and I paste in that information, I can actually search for more details. So what it provides me here is basically the same information that we also saw integrated in the GitHub portal out of the Dependabot capabilities. It's highlighting some additional details. And then from here, also useful is where other vendors, sometimes security vendors like Snyk is a code scanning security tool. Obviously, GitHub itself, I'll talk about it in a second. But then also Oracle is listed in this example. There's a few other where I'm going to highlight NetApp, not any specific reason, but what you could have in this case is, for example, NetApp in this case is storage vendor, if you're not familiar with them, also highlights this as a security risk, which might mean that inside their NetApp software products, they're actually using that JavaScript engine. As you can see here, it's clearly described, and it's now also referring to that CVE and highlighting the risk aspect of it. So if you build any of your custom software, you're going to integrate those packages, but now you could also use it to actually validate other building blocks in your environment. If we switch back to our GitHub scenario, we also have our built-in GitHub advisory database. So what we can do from here is, again, using the GitHub definition, GitHub clarification, how they detected the problem. Now, you're going to see here there's quite some overlap maybe with the official CVE org database information. But the use case here is that you might have a vulnerability getting detected out of Dependabot, which might be listed in the GitHub advanced advisories and maybe not even listed in the CVE, or obviously the other way around. Got a few other options that I want to show you. So let's take a step back. Back in the repo, we have our Dependabot, but then we also have that dependency graph. How do you get to the dependency graph? Well, you open the repo, you navigate to your insights, and then here on the side, you can pull up the dependency graph details. Once we navigate to dependency graph, you're going to see that it's listing up not only one package in this case, but listing up all possible packages. I can use the Dependabot tab up here, and that's going to show me, again, specifics about any version updates. Because remember, Dependabot is not only used to detect the vulnerabilities like the vulnerable packages, but also recommending any mitigations and typically version updates. So what you can do here, and again, in this example repo, we have a JavaScript package JSON, so technically the text file, if you want, with all the packages that we need. We can look into recent updates. Now, don't worry too much about the error messages here. It means that there is already an updated version available, so there is a pull request. I tried multiple demos all at the same time, and every now and then you can imagine that some of those are conflicting. Now, what it gives you here is a more detailed logging. Now, in this case, there's not too much, but it's going to show me the actual logs of my Dependabot task. Now, before I talk about the tasks or my workflows, let's take one little step back into dependency graph, where now we can export that software bill of material, which technically, again, is nothing really more than a JSON file. It's obviously opening it up in VS Code in my case, but then if I do my formatting, you can see that it's traditional JSON, but all the details from the packages that we have out of the package manager, who's the owner of the package, what are the versions, and all that information can be reused from here. Next little piece is the Dependabot options within the GitHub Advanced Security. So again, the starting point could have been go to security, enable Dependabot, and then read out the information. That's typically picking up the default options. Now you can make this more granular for your specific example. And again, remember, I don't have the organization or enterprise level in my demos, just to keep it a little bit easier and also more applicable to everyone, not just the customers having the enterprise edition. But what we can do here is navigate to advanced security and then defining specific options for Dependabot. So again, dependency graph, getting more view, better view on your dependencies, enable or disable. I would recommend you to enable it and never disabling it. And then inside Dependabot itself, you have a few different options. I'm not going to walk you through all these options because they're quite specific. But for example, the one that I usually enable is the security updates, which means there is a vulnerable package getting detected, and we're going to look into it from a security perspective. And then maybe this one is also allowing Dependabot to actually open pull requests automatically, making sure that it's taking away some of the manual reviewing work and code rewriting work for you. That's where we obviously have an interaction with our YAML pipelines. So once we enable Dependabot, inside the actions, it's creating a Dependabot update little workflow task. Out of that task, you can see there's quite some history in this sample because I've been using this for most of my demos on the Dependabot. We can look into each and every of the cycles. My Dependabot job is running. And then inside you have all the details. And this is partly, again, JSON based. So if you want to export some of this, you can obviously definitely do that. And then you can see that it's looping through different individual tasks. And then eventually running more tasks. And over here, it's looking into the different Git steps, cloning, taking actions against the repo, uploading the package could be one example. And then all the way at the end, it's going to highlight the different updated tasks that it performed. If I move to pull requests, you can see that all of these actions are basically linked to those pull requests. So a big part, I would say the benefit of Dependabot is not only detecting vulnerabilities, but also automating a big part of the process and integrating potential updates, making your life as a DevOps engineer or maybe a repo admin a lot more user-friendly. Last part that I want to highlight is the Dependabot dependency review. So remember in the presentation piece, I talked about it, but I didn't really drill down on all the details, meaning the differences between just using Dependabot and Dependabot dependency. So I'm going to explain a little bit using the demo. So what is the dependency review? It's first of all a specific action out of the marketplace. So what you can do is create a new action, you search for dependency review, and you're going to configure your task. It's a built-in GitHub Actions task, which means down here in my code section, we're going to run an action checkout, which we always have in GitHub Actions pipelines. And then from there, we're going to add a new action called dependency review action. I'm not going to use this one because I already have another sample pipeline, which technically does about the same. A few details here, but I just use the defaults. We run this pipeline out of an automatic trigger. So whenever there is a branch or the main branch update, my pull request is kicking in, and that's triggering the pipeline action. The job we're running is identical to the previous example I showed you. Use the action dependency review. So nothing too specific, it's just an actions pipeline. What I did in preparation for this demo is navigating to my Ruby folder. This is a Ruby example. Gem is where you use like package management. And what we can do here is updating the package file where I'm going to add an example package, but it is actually a known one called Nokogiri, and that's just the name of the package. And I think it's respecting the syntax, that's good. And version 1.10.0 is the one with known vulnerabilities. And I'm going to add a little comment. This is just for the demo. I'm saving the changes. I'm going to use a new branch, or maybe keeping main because my pull request is linked to main. I added the new package. And then here you can see that my dependency review task obviously started running. I speed up that part or remove that part from the demo recording. But what it does here is providing more insights. So it detects a vulnerable package. By the way, it also identifies that I didn't update my open source license. But then more below, it's showing extensive details about the vulnerabilities. Now, up to this level, you might go like, okay, what's the difference now between using the built-in Dependabot and using an additional dependency review pipeline. The big difference is the review is literally doing the review. It's going to detect probably about the same. I didn't check it for all of my repos, but I'm pretty sure that anything that the dependency review will detect as a potential package vulnerability will be detected by Dependabot as well. The big difference, however, is that instead of just running the review to identify vulnerabilities, Dependabot is adding not just the detection, but also allowing you to automatically fix and getting that recommendation to fix it. So it's a bit more automation. It's a bit more not just detecting, but also providing the mitigation steps. Closing of this is why not enabling both of them? Again, there's a bit of overlap, might be a bit specific for your repos, your company policies. I heard from customers, some of them are using dependency review just to get a view on the vulnerabilities, and then obviously preferably also enabling Dependabot on top of that. I think that's pretty much it on this part of the demo. So let's go back to the presentation to wrap up the module and getting ready for the next one. The goal of this module was to explain how you can use GitHub tools to help manage your dependencies and identify vulnerabilities that can affect your project security. You learned how to configure your notifications based on how you want to receive alerts about those vulnerabilities in your code repository. You also learned how to use the Security Digest email as a concise way to receive daily or weekly summary of those alerts. And then finally, you learned about dependency review and how to configure the dependency review action to analyze dependency changes on every pull request. Using these tools makes it easier to understand and manage your dependencies to overall better protect your projects on GitHub. There are many ways to continue your learning journey. I encourage you to watch other videos in this course or search for your next favorite topic on Microsoft Learn using aka.ms/learn. Thank you so much for learning GitHub Advanced Security features in this training. Let's continue the path of integrating even more security into your GitHub repos by jumping to the next feature called secret scanning. Grab a drink, maybe grab a cookie, and get ready for more. I'm going to see you back in the next video.